Okay, good morning, guys. Sorry for the little bit of delay. Let me share my screen with you guys. Okay, so let me go to the home page so we can talk about that for a bit. And I got some of your emails. Some people emailed me about Unit 3. I replied to you guys. So you can go ahead and drop that off. Okay. You should be able to drop it off now. Let's see. Okay, we acknowledge we are hosting the lands of Mississauga of Anishinaabe and the Haudenosaunee Confederacy and the Wendat. We also recognize enduring presence of all First Nations, Métis, and Inuit people. Okay, so okay, so I see there's another something directly to my. I'll get back to you after that. Okay, so Unit 3 people that still need to whatever submit Unit 3 because they missed that deadline. It is open. Okay, you can drop it off, but it's open for a limited period of time. So please drop it off. It was due yesterday. You had the whole weekend, and now we're going on to another day, right? You have to know that, you know, you got to meet these deadlines because things keep coming fast and furious, right? Let me go to the course outline just to kind of show you. There's things coming up next. And maybe look at the horizon. Where's the course outline? So you can see the course outlines here on the home page, right? So hopefully you guys would have went and checked that to see, like, the deadlines are there for a reason, right? Because you can't hand in Unit 3, Unit 4, Unit 5 all in the same time, the same day, and expect me to mark it, right? So you guys got to really get a handle of on these deadlines, okay? For whatever reason, it's like in life, right? This is teaching you life because if I'm working at a job and I have a deadline for my company and the deadline affects hundreds and thousands of dollars, I can't just miss it for whatever reason that's happening. Like, I know there's legitimate reasons. That's not what I'm trying to say. But even in the real world, when there's legitimate reasons, you still got to try to make that deadline. Okay. So I'm giving you guys some real experience in life. You know, so here it is right here. Where are we? Unit trigonometry. Even though this is Unit 5, it's Unit 4. So we did this yesterday. We did this today, right? So there's a quiz for this today. It's due today. Okay. And then there is a review quiz that doesn't count for marks for the trig. Okay. And then I'm giving you a test today. Okay. The test is going to be open after this Zoom session, but it's saying due tomorrow, but I'm actually going to give you till 20th. But I can't go past that because you guys didn't say I have to give you the 20th is what day? Wednesday? Sorry, yeah, it's Thursday, right? So I'm going to give you till here, but it's pushing it because you know what? We got to go to Unit 5, and then there's things happening in Unit 5 that's due on the 20th, right? And then you got on Friday, this Friday, I'm going to give you the part 1 of the collimating. Okay, so in the collimating, part 1, part 2 are both worth 30%, right? So these are things I still have to mark for those people who are worried. You know, the mark is low, or will they pass the course? That kind of stuff, because the drop deadline is the 25th. Well, I have to still mark Unit 3 test. Hopefully that's better than the other test. I still have to mark Unit 4 test. And then you have Unit 5, this one here, Unit 5, that has 2 multiple choice. So it's not even handwritten tests. It's 2 multiple choice. Okay, 2 multiple choice tests. All right, that I have to mark. But they're multiple choice, so that means they're not, I mean, hopefully they're easier. And you're given multiple attempts. So hopefully that helps to bring up your mark. And then you have the collimating, which is worth 30%. Part A is multiple choice. Part B is written questions like you do for the unit tests. So there's plenty of marks that can still come your way to improve your mark. So don't be concerned on the midterm mark per se. You should be concerned with the final mark, because that's the one that stays on your report card that, when you go to grade 12, okay? So you still have time. Midterm is just like a flash. It's just like a snapshot. When I took a snapshot, that's it right now. But be concerned with the final, so you got to do well towards now and the end, okay? So that is important for you guys to know, okay? So again, I'm going to go through this lesson. We're going to go through periodic behavior, periodic functions, transformations, sketching, graphs. So there's a lot to cover a little bit. So I'll cover as much as I can, and then I know there's YouTube videos, okay? And then there's a quiz on this. And then also too, there's a test on this, which is due on Wednesday, but I'm gonna give you till Thursday, and I can't go past Thursday, but really focus on Wednesday. Focus on getting this done tomorrow by 11:59, okay? Because it just keeps coming. That's the whole point about this course. It's fast and furious, like the movie. Okay, so let's go into, okay, let me view it as you guys first, because it makes things easier if I view it as a student. Okay. So Trig should receive some video. Okay, so is it this one? Okay, we did this yesterday. Angles. We did this yesterday. Okay, something's going on. Let me maybe view it as a teacher. It's like there's something's missing here. Maybe it's closed off. Okay. So we're gonna go through periodic. Okay, so let's go. This one here there's no video, so I'll go through this one. And then there's a video for the next one. And yeah, so let's go through this one quickly. This lesson here. Okay, so periodic behavior. So let's maximize the screen here. Zoom in. Okay, so we need to understand the periodic behavior. And when we're talking about that, because we've been talking about sine, cosine, tangent, right? Basically, their periodic behavior means that something repeats after a certain amount of time. Okay, so that is the key. Something repeats after a certain amount of time. So now let's look at what the definitions are. A function that has a pattern of y values that repeats at regular intervals. Okay, so that's a periodic function, right? And that is the whole idea. So your y values repeat after regular intervals. Cycle is one complete repetition of a pattern. So let me give you an example, because I'm talking and I think I'm just giving an example. Oops, my pen doesn't work because there's no battery in it. My pen inside, learn to learn battery in the pen. Okay. Give me a second. Okay, my pen now should work. So here is, your X and Y. And when we say something repeats, so this is what we're talking about. Okay. So you can see it repeated. So it's gonna repeat again, but it started here, and then it ended here, and it's gonna repeat. So that is like a one cycle, right? And it can continue for basically, if you're looking at the range or the domain, it can continue forever, right? But if you're looking at the range, which is the Y, it has a limit. Okay, so that's what we're talking about. We're talking about, that's a periodic function. Okay, the period of length. So period is the horizontal length of the cycle of the graph. Okay, so the X value is how long is the length of time it takes to repeat. Okay, the amplitude is this between the max and min of the periodic table of the periodic function. Okay, so let's get into examples because we need to see that. So here we go. Okay, so if I look at this one here, determine whether the function is a periodic or not. If it is, state the period of the function. Okay, so let's look at this. This is a periodic function because it repeats. You can see here's one pattern, and then the pattern repeats again over here. So the period is for one cycle of the pattern. So it takes, the period is going to be -6 because it's from here to here is how long it took to repeat. Okay, and it repeats again. Now here you can use, in periodic functions, your X can be the angle, can be the time, it could be, basically is an independent variable. So time is independent variable, angle is independent variable. So that's what usually you have on the X-axis. Okay, and Y could be something obviously is dependent on the X. Okay, now we're looking at this one. Is this one a periodic function? No, because nothing here repeats. Okay, so it's not a periodic function. And then we can look at this one here. This is a periodic function? Yes, it is, because you can see it repeats. It repeats like right here, from here to here repeats, from there to there repeats, from there to there repeats. So repeats. That's what, and then the question is, what's my amplitude? Your amplitude is the difference between your max and min, and you divide it by 2. So the amplitude, it says right there, the amplitude is half the difference between the max and min. Okay, so the amplitude is the line that's in between, is the distance in between your max to your midline, or your minimum value to your midline. Okay, and here it is a repeat. Yes, it does. Okay, the period repeats it, like from here to here repeats. Okay, and what is my amplitude? My amplitude, and the amplitude, and let me use a different color. Let's use black. The amplitude is basically the midpoint between your max and min. Okay, in between your max and min. Okay, so if my amplitude from here to here is 5/2, I guess 5/2 is 2.5. Right, from here to here is 2.5. That means from here to here is 2.5. Okay, right, and you can see here, if you look at it, 3 to -2, that difference is 5, right? So that means in between would be 2.5. Okay. Wherever 2.5 falls under, right? Okay. Then let's go down to the next part. For the function. Okay, so now with this one here, for the function, it's saying, you know, determine what is f of 2 and f of 5. Well, that's kind of easy. All you do is look at, okay, when f of 2, when we say what's f of 2, we're saying the y there, what's the y, and what's the y there, right? What's the y there? So when y is 2, when x is 2, y is 1. When x is 5, y is 0. Okay, you can see that right there. Okay, and you can see that on the graph. Okay. Give me a second. Okay, so we go to here, right? So then basically here, what is y when x is 8? What is y when x is 10, and so on, right? Again, you can find that from the graph. That's not a big deal. Okay. So here is an example of a problem question. Okay, cutting machine chops strips of plastic into appropriate lengths. The following graph shows the motion of the cutting blade on the machine in terms of time. Okay, so in terms of time, okay, so you have, here's my x's time, my height, right, which shows the height of the cutting blade, because the blade goes up and down. This is what the actual happening here, but you can put that into a periodic function, right? Because the blade coming down, it comes down at a certain cycle, meaning maybe every 5 seconds, it comes down and chops. Every 5 seconds, it comes down and chop. This could represent like a machine at a factory, okay? The machine at a factory is maybe cutting pieces of plastic, and they all have to be the same length. So in order for them to be the same length, it has to cut it at the same time, at the same spot. Okay, so basically, and coming down from the same height, right? So the height where it starts is at maybe 0.5 centimeters above the ground, right? And then it goes down. So let's say the beginning here goes down. Let's say this is 3.5, then it rises back up. And then when's the next time it goes down again? At 7.5, and goes back up again. Okay, so from here to here, from that period or that point to that point, I've repeated, right? So we can say 4. It started at 4 because you gotta find points that make it easy to do calculations, right? So it started at 4, and it went back, and the beginning part is at 8. So then if I look at that, my period would be 4. Okay, would be 4 sections. 4 seconds is my period. Now my amplitude is made up of your max height and your minimum height. Subtract the difference and divide by 2. So if I subtract the difference and divide by 2, okay, so my max height is 0.5, my min is 0. Subtract the 2, well, it's going to be 0.5, and divided by 2 is be 0.25. So that's what you got here, right? Max and min, max minus min, da da da. So my amplitude is 0.25. and my period is 4 seconds. So every 4 seconds it repeats. In my midline of the max height and the ground is 0.25. Okay. Okay, now it says here, state the next 2 times the blade will strike the cutting surface. Well, you could basically just say the next 2 times would be right now, or hitting the cutting surface, right? So it hit the cutting surface at 7.5. So we know it repeats every 4 seconds. So if it hit it at 7.5, it will hit it again after another 4 seconds, right? So there you go. Here it hit the ground at 7.5. I add another 4. That's when the height is going to be 0. So 11.5, the height is 0. And then if I add another 4 seconds to 11.5, that'll take me to 15.5. That's when it hits the ground again. So it repeats every 4 seconds, it'll hit the ground. So these are the times it will hit the ground or hit the table or hit the striking of the surface is 11.5 and 15.5. Okay, so you can see how that repeats. So we went through that lesson. Okay, let us minimize the screen. Okay, so, and then there's questions on that, right? So you can go through the questions. Here is graphing of the periodic functions, right? So here's a graph of the sine, cosine, and tangent. So we'll go through that a little bit. The main ones you really want to be looking at is the sine and cosine. This tangent one, it's complicated. You can see there's asymptotes every because yeah. Let's go through the lesson before I start talking about it.
A lot of people don't know this, but the best way to make money on YouTube in 2023 is not by becoming.
Let's look at how we can relate the primary trig ratio, sine, cos, and tan, to the unit circle. Remember, a unit circle is a circle centered at the origin with the radius of 1. How we can rate the three primary trig ratios to this unit circle, and then use that relationship to help graph what sine theta and cos theta actually are going to look like graphically. So we'll graph sine theta in yellow there. We'll graph cos theta in green down here.
Okay, so the reason why you're showing a circle, we're coming off the circle, which is a unit circle. The reason why we call it unit circle is because the radius is one unit. That's why you have 1, 1, 1 here. So it's relating to the unit circle, right? My y value can't be any bigger than 1, because when you think about it, if this is a circle and the radius is 1 unit, that means my y can never be bigger than 1, and it can never be bigger than or lower than -1. And my x can't be any bigger than 1 or less than -1. Okay, so that's what we're doing. But also too, when we're looking at the unit circle, there's degrees here, right? Because we're going in a circle, so there's a degrees. So you have 0, 90, 180, 270, 360, right? It goes like that. So, and things, if you were to have like a terminal arm, it can repeat. And we just did yesterday where some trig ratios repeat at different angles, right? So you can get a trig ratio that will repeat, say, in this quadrant, because remember this quadrant here that I'm using my mouse, this quadrant, if you do the cast, this side is, I'm using black, you're not gonna see nothing with black. This is A, C, A, S, T, right? So trig ratios can repeat in A, and if I'm looking at sine, it can repeat in A quadrant and also in sine quadrant. Or it can repeat, if I'm talking about tan, it can repeat in A quadrant or in the tangent quadrant, because this one says all, right? All of these trig ratios are positive. This one's going to be positive only in this quadrant, the sine. The tan is going to be positive only in this one, and then cosine is going to be positive in this one. So there's a correlation to this graph that we're doing here, and then this unit circle graph, okay? And that's what he's going to explain. So let's go through that.
But first, let's remember the relationship between the primary trig ratios and the unit circle. So keep in mind, three primary trig ratios are sine, cos, and tan. And you know the word SOHCAHTOA tells you that sine of
Okay, so let me just fast forward a little bit so we can get into some stuff here. We talked about the SOHCAHTOA stuff. Okay, so okay, let's see where we are.
So it just tells you the distance between the x-axis and the point that intersects the unit circle. Cos theta is equal to,
Okay, we know cos theta, we know sine theta. So let us get back to graph. Okay, so he's talking about it about here. Let's go back just a little bit.
y. So if I want sine of 0 degrees, I just need to look at the y coordinate of where it intersects the unit circle.
Okay, so we know, so the other thing too we should remember is that that is your y and that is your x, right? Your y is made up of is considered as sine theta, and your x is considered of cos theta, okay? Because it's a unit circle, right? The values of the x and y make up your sine and cosine trig ratio, okay? So there's going to be a correlation now. Whatever value it is for my x and y, that means it's going to be the value for my sine and cos, right? That's what's going to mean. So over here, if I go over here, my x and y would be, my x would be 0, my y would be -1. That means my x is 0, my y is -1. That means my cos is going to be 0 and my y is going to be -1. This will correlate to this graph here. Okay, your sinusoidal graph. It's going to correlate, and then this one here too. Okay, it's going to correlate. So let's go. Let me clear that.
Circle when we've rotated 0 degrees from the initial arm. The y coordinate is 0. So sine of 0 on the graph is going to start right here. It's going to have a sine ratio of 0. What if we want to do sine of 90 degrees? What if we rotate 90 degrees and now it's going to intersect the unit circle right here at the point 0, 1. Well, the y coordinate of that point is 1, so sine of 90 is equal to 1. So when we've rotated 90 degrees, the sine ratio is now 1. And now that's the furthest we're ever going to get from the x-axis as we rotate around the unit circle. So the biggest the sine ratio is ever going to be is 1. So when we've rotated 90 degrees from the initial arm, the sine ratio is 1. What if we've rotated 180 degrees? We've rotated 180 degrees, it's now going to intersect the unit circle right here at the point -1, 0. Well, the y coordinate of that point is 0, so sine of 180, we are back to 0. So the ratio, when we rotated 180 degrees, is back to 0.
So if you can see, he's plotting on this graph here, and I'll kind of fill it in. I'll use blue, but you can see I'm gonna move this out of the way so I can actually draw. That it's gonna be like this, right? Right, something like that. Over here, and this is a sine curve, right? So when sine is 0, right, when the angle is 0, so sine is 0, my y is 0, my x is 0. Okay. Well, we're saying, well, yeah, my x is 0 and my y is 0. When it's sine 90, right? Sine 90, that means my y is 1. And if you look at the unit circle, my y is 1. And then when it's 180, when my angle is 180, my my sine is 0. Okay. And when the angle is 360 over here, my sine is 0, right? So, and then this will be opposite because remember, this is dealing with here is dealing with your y component of your coordinate on the unit circle. Okay. And this is going to deal with the cos, will deal with the x coordinate around the unit circle, right? And then from the unit circle, you draw on the sinusoidal the waves, and it repeats. Okay, so he's going to go through that a little bit more. Let me just clear this so I can watch.
How about when we've rotated from the initial arm, when we rotate 270 degrees? So the terminal arm is now going to intersect the unit circle right here at the point 0, -1. Now that has a y coordinate of -1. So sine of 270 is equal to -1. So 270 is at -1. And how about if we rotate all the way back around to the start?
So that's what you get, right?
Continue. Remember, this function is periodic. So this pattern of y values oscillating between 1 and -1 is going to continue every 360 degrees. And we could also rotate in the negative direction. We've rotated 270, the x coordinate.
So now we're doing the x coordinate over here, right? The x coordinate, right? And the x coordinate is made up of the cos, right? So now you're going to be plotting the x coordinate here for the unit circle, and basically that's your cos values of the basically coordinates around the circle, right? So you're going to have something like that, right? When the angle is 0, the angle is 0 here. What is my, on the unit circle, what's my y and x? Or actually, let's look at x. What's my x? When the angle is 0, my x is 1 up there. When the angle is 90, my x is 0, right? When the angle is 180, my x is -1 down here. And when my angle is 270, my x is 0. And when my angle is 360, my x is 1. So it goes up here again. So see how it repeats? This repeats, okay? So we're done with that. Okay, and basically, here is the lesson in words, what I just went through. Let's just look at that. Okay, so this one here, we won't go through it, but basically, everything here is coming from your, is basically this is my sine graph, right? It's coming from the unit circle, okay? So I won't go through this because we kind of went through it with the video. So let's go on to the next thing. Transformations. Oh, transformations. Oh, well, everything has to move again. Just like in exponential functions, things have to move. In trig functions, things also move again, right? The trigs move. Okay. So transformation of sine, cosine. Lovely. Right? But it's the same kind of thing. Yeah, you have your A, your K, your D, and your C. Okay. Same kind of stuff here. Let us. Does that do? No, that's not due today. If I do that, that means due tomorrow. Let's just double check. What was on the agenda? Was it transformations as well? Yeah, transformations. Okay, so I'll do transformations. Interesting. Let me just check something here. Yeah, that's it, because you know what? This is the last day for unit 4. So it is all of this. Okay. So all this is in for the test that's going to be opened up later on today. I mean, right after this session. So let's go back. So let's do the transformations. I have to change the date, but it doesn't matter. You guys don't really submit the worksheets, I noticed. So let's go to transformations. Okay. So let us look at it like this. Zoom in. Okay, so when we look at the transformations of a function, we have similar values that we had for when we did transformations of a quadratic, transformations for the last one was an exponential function. We have your A, we have your D, and your C, and your K. Okay, so those things. The only thing is now things may be a little bit different as far as naming. A is your amplitude, which can be a stretch or compression of your sine function or your cosine function. And then K is the period. K value gives you the period, and the period's equal to 360 divided by K, right? So horizontal stretch or compression is by a factor of 1 over K. So I have a K, that means I have to have 1 over K to determine if it's a compression or stretch. If the value of 1 over K is greater than 1, then you know it's a stretch. If the value of the 1 over K is less than 1, then you know it's a compression. And then you have your phases. That's basically your up and down. And then you have your phases is shift left and right. And your vertical is basically up and down, okay? So now when we look at this is a basic, this is what we call the parent function. This would be the parent sine function, right? So when my angle is 0, X is the angle now, okay? So maybe we need to understand that X is your angle and Y is your Y, but this is your angle. So X is 0, Y is 0. When X is 90 degrees, your Y, and this we did it from the video, right? So this is just showing the parent function. And then we want to basically transform this. We want to either stretch it up, compress it, shift everything up. So that's what we're doing with the transformation. Here's your cosine. Now here's an example of a transformation. Simple one. My original sine function is y is equal to sine over x, sine x. So now what's happening to your transformation is when you look at it, my y is in front of the sine, so my y is going to double, it looks like my x's nothing changes with my x's, right? But with my y, it changes. My y coordinate, it will double, and then you add 1. So if I do that, if y is originally 0, it goes to 1. If y is originally 2, goes to 3. Okay? So there's a transformation where looks like it's stretching and then it's moving up. Right? So it's stretched a little bit and it moved up. So the center line, that's your midpoint, is based on what's the amplitude. So with my amplitude, right? My amplitude of this. Now, how do you figure out what the amplitude is? Well, my amplitude is going to be it's going to be 2. Now, how did we get 2? 2 is up here. 2 is what you have there, is the number in front of your function, your trig function, right? Because when we go back to the beginning, here, A is your amplitude right there. The number in front of your trig function is the amplitude. Okay? So when we go back to here, oops, went too quick. A is my amplitude. Now then the question is, what is my K? K is, K is 1. Okay. My bad, K is 1. But then you need to have K in order to determine the period. Because when we go back up here, right? My K is 1 because you can see there's nothing in that function there. There's no number there, so therefore it's 1. But K you need to determine for your period. So it'd be 360 divided by K. And if K is 1, then 360 divided by 1 is still just 360. Right? So my period is 360. What does that mean? Every 360 degrees, it repeats. It started at 0, and then at 360 again, you can see it's going to start repeating. So that is my period for this function. And then the question is, how many cycles in 360? In 360 degrees? Well, it only repeats once. So it's only one time the cycle. You only have one cycle in 360. Okay. So let's look at another example. There's a little bit more stuff happening in this one. You can see my y is equal to this trig function, right? When I look at it, my amplitude is the number in front, so my amplitude is negative 1.5. Okay. My K is 3. That means my compression or stretch will be by a factor of 1/3. Well, 1/3, since it's a decimal, that means it's going to be a compression. And then here I have 30 degrees. So that means it moves 30 degrees along the x-axis. And then 0.5, that means it moves up by 0.5 on the y-axis. Okay. So here's my regular parent function of my cos. Okay. That's what I have there. And then here is my transformation. So if I just look at the x, my x values are made up of the k and the d. Okay, k and d, right? This 30 is gonna be the d value. Just like, let's just go back up. I just want to make sure you guys understand what I said, right? The d and the k represent how it affects us on the x. The a and the c represents how it affects us on the y. So if I want to look at how it's affecting on the k, sorry, on the c, on the d, sorry, if I want to see how it affects the x-axis, then I look at k and d. So let's look at k and d for that question. So my k is 3, that means my factor is 1/3. So it's going to be 1/3 that's going to apply to the x. And then my phase, which is C, is 30 degrees. So for every x that I have here on the original parent function, I have to divide it by 3 and add 30. So what? 0 divided by 3 is 0. And then if I add 30, it's going to be 30 degrees. Now I go to the next one. 90 divided by 3 is what? 30. And then I add 30, it's going to be 60 degrees. 180 divided by 3 is 60. And then 60 plus 3, so plus 30 gives you 90s, and so on, you can see. And then my y value changes based on this transformation. I got negative 1.5. Okay, how to get negative 1.5? That's the A. And then my 0.5 is the C, right? So for every y value here, I applied negative 1.5 and then add 0.5. And that's how I got these numbers. And if I plot this, you can see that it's shifted. This is a cosine function, but it's shifted, right? Normally a cosine function, so we know how the parent function looks. Let's see that. Let me draw the parent function up here. For a parent function, for the cosine, we know it starts up here, and then at 90, it's 0, right? Yeah. And at 180, it is at -1. See this, you can see how wide this is right now. The original is going to be wide. And then at 270, my x is 0. And it goes off, because it has to go all the way to 360, right? So this is the original function. It's supposed to go up, right? But now look how much it shrunk, right? This is the original function, but you can see now this one here, it shrunk. Put it this way, it got stretched, and then it also shifted. It shifted up, right? It shifted up. Okay, so basically that's sort of the gist of that. Let me just cancel this. Okay. And here is, so okay, let's just finish this one up. The amplitude is 1.5 because that's what you get from the equation. The period is now 1 divided by, it's 360 divided by k, so it becomes 120. So the original, so this repeats every 120, right? Now that makes sense because you can see when I drew it, and it's the original parent function, the period is 360, right? The original, this one here, you can see it's 360. It repeats at 360. You can see here at 0 to 360, it repeats at 360. Over here, this repeated at 150. So you can see there's more of if you're looking at between 0 to 360, this will repeat more times than this one between the angle of 0 and 360. This only does it once. This one can probably do, if I do, looks like it repeats every 150. So that means at 300 it's going to repeat again, while this one is still trying to do its first cycle. Okay. And then here's another example. Okay. And then so on. I'll let you look at this example on your own. You can see all the the transformation and the original. Okay, so let me stop with this one. You guys can do that on your own because we're running out of time. And then there is a lesson worksheet for that. Here is the lesson for an application question. So let's just let's see how much we can do in the amount of time we got. I think I got, probably have to go to 10:10. Okay, so we're gonna zoom this. So this is just saying, remember the unit circle, which we do. Don't have to repeat that. So we know the values of on the unit circle, X and Y. X would be your cos, Y would be your sine. Okay, and tan, obviously we know tan from other lessons that tan is equal to either sine, it's the sine divided by cosine, right? Okay, so sine function. Yeah, I got your Zane, I got your thing. Okay, so let's look at this example. Modeling with graphs. You are in a car. You're in the car of a Ferris wheel. The wheel has a radius of 8 meters and turns clockwise. Let the origin be the center of the wheel. Begin your sketch when the radius of the center of the wheel. Let's begin your sketch when the radius from the center of the wheel to your car is along the positive x-axis. Okay, so if you're looking at sketch a graph, vertical displacement. So imagine this whole thing is a Ferris wheel, the circle here. Okay, at this point here, where my mouse is, the x is at 8. That's just basically the radius. It can't be any bigger than 8. And then I'm on the center point, which is going to be 0. So you can see how this turning will represent a sine curve. The only thing is that, so since this is your radius, right? When you are to draw this out, you're going to be having it go to 8, right? Instead of 1, because this is not a unit circle. It looks like a unit circle. Unit circle would be 1, but this is the radius of the Ferris wheel. So basically, and we're looking at from the center of the Ferris wheel. So that's going to be at 90. The radius is the max, right? Is going to be 8, and when it's at -8, the angle is at 270. Okay. Now it's saying do the same thing for the cos. Well, again, we know that between these coordinates, the 8 is the cos, the y is the 0, the 8 is a cos. Sorry, the 0 is a cos here, and then y is -8. So you draw the same circle, right? And now you want to do it in form of cosine trig function, right? So when x is let's look at this again. When x is 8, y. Oh, actually, let's look at it from here. When x is 0, y is 8. Okay. This is supposed to be 8, not 9. I don't know why it does that. That's 2, 4, 6, 8. 2, 4, 6, 8. That's not 9. It's supposed to be 8. Okay, so don't get confused there. That's supposed to be 8. I was going to be confused. So when x is 0, y is 8, right? And then when x is -8, I shouldn't say -8. When X is at 180 degrees, right? Then my Y is -8, okay? So now, this is just telling you the relationship between cos and sine. That's all it's telling you. So here's a real question now, a real problem question. The real problem question here is a carousel rotates at a constant speed. It has a diameter of 15 meters. A horse that is directly in line or in the line with the center horizontally rotates around 3 full times. Create a graph that models the horizontal distance from the center as the horse rotates around. Okay, so the horse rotates around the Ferris wheel. The diameter of the Ferris wheel is 15. So the horse, say the horse is over here. I'll put a little sticky person here. Say the horse is over here, right? It's going to rotate around, right? It's going to rotate around, right? So that rotation is the path of the horse compared to the center. So from here to here, you know, it's 15. Oh, sorry, not 15. I'm going to say not 15. It's actually 7.5. The diameter is 15. So you know the diameter is actually 7. Right? Right? Diameter 7. So that tells you that, or 7.5. That means my max is going to be 7.5. Okay. And my min is going to be negative 7.5 on my trig ratio on my graph. Okay. So 7.5 and 7.5. Okay. Now what has to happen is, what's it asking? Create a graph that models a horizontal distance from the center. So, you know, your max is 7.5, your min is 7.5. So now you want to basically get these points on this unit, on this circle, and you plot them here. That will, and then you draw the line, that will give you your graph. Okay, so when X is 7.5, Y is 0. When X is 0, Y is 7.5. Sorry, when X is 0, we know Y is 7.5, but my angle is 90 because we're writing this in angles. So you go there, there. And when my X is negative 7.5, sorry, we're dealing with Y for this, right? When my Y is 0, my angle is 180. When my Y is negative 7.5, my angle is 270. And when my angle is 360, my Y is 0. Or sorry, my Y is 7.5. Okay, that's what you're doing with that. From here to there, and just repeat that. Okay. Let me clear that. Okay, so let's scroll down. Here is another example. Modeling equation based on the graph. So you're gonna have to have a graph and then come up with the equation from the graph. Okay. So if I look at this graph here, I can figure out what's my amplitude. right? The difference between your max and min. I can figure out what's my period, how long it takes to repeat. I can figure out what my center line is. My center line is the max plus the min divided by 2. Or you can say the max, which is 11, minus the amplitude. We know the amplitude to be 5. So the max minus the amplitude will give me the value of my center line, which is here. So my max is 11 minus my amplitude. My amplitude was 5. Therefore, my my midline is going to be 6. Okay. Now there's a couple of things that are new here: d cos and d sine. Okay. D cos represents. Let's go back up here. It's not showing. Oh, d cos wasn't actually in our. We have to go back into the previous lesson, but it'll show you how you can get d cos. But we're going to go here because time is wasting. My d cos is basically when I get to, when's my max? When do I get to my max height? What value is my max height at? What's the value of x when I'm at my max height? The value of x when I'm at my max height, the first value of x of when my max height is, it's going to be up here. So my x is going to be 10. Okay, that's my max height. Okay, so there's a relationship between d cos and d sine, and the relationship is this formula there. Okay, so that formula allows you to find the d. Well, you know the d cos is that your maximum value of y. What's the x value? And then in order to get the sine, the d sine, all you're going to do is it's going to be this formula: 90 minus my k value. So if my k value here is 4, 90 divided by 4 gives me 12.5. Sorry, my bad. I didn't. I have here 10. So 10 minus 90 divided by 4 gives me 12.5. That will basically give me minus 12.5. It gives me my d sine, because what happens is you can write the equation 2 ways, right? And that is what we're showing you here. You can write the equation, this equation here, this graph can be written in using cos, or it can be written as using sine. So you can see here, I wrote it using cos, and I wrote it using sine, right? So you can see here, my d sine, which is what goes inside here, was negative 12.5. So I put here negative 12.5. My d cos was 10, so I put here 10. Right? And the same thing applies. If it's a negative, that means when I go into this equation, it has to be a positive. And my 6 is my center line, my new center line. So my new center line is 6. I figured it right there. Okay. So you need all these things in order to figure out the equation. And then the question would be, well, what's John's height above the ground after 78 seconds? Okay, so 78 seconds, this whole thing is done in seconds. So all I have to do here, put my x value inside here as 78, or I can do this one, doesn't matter, and then plug it in here, and I do the calculation, and then get my max, when my height is 66.2 meters at 78 seconds. So 78 seconds. So probably about here. What's my Y? 6.2. So somewhere here. 6.2. Yeah, my bad. 6.2. Okay. Here's another example, but I'm gonna have to stop here because we're running out of time. Okay, so I'm gonna stop recording. I'm gonna share this. Let me actually, before I go back, let me share one more thing. Okay, so we close this. Okay, so going back to here, like I said, people, the unit 3 is opened. And let me just see. I just opened it up. So if you didn't submit your unit 3, please submit it. Let's see. Right, so some people haven't submitted, it looks like. So you can still submit. You can see I expanded it for today. Okay, so people still submit it. So I don't know if you can't submit it, then find a way, right? Because I opened it up for you, you can see. Okay, and then the test, I'm going to open it up today, and it's going to be due on the 20th. No, my bad. It's going to be due tomorrow, but I'm giving you until the 20th. Okay, so I'm going to do these things right now after the meeting. And yeah, so there's also a quiz for today for the stuff we did today. So do that. Got 2 tries for that. Okay, I'll look into that. Okay, so we'll look into that, Zane. Okay, after the meeting. Okay, so that is it, guys. Let me stop sharing. I'll let you guys go do your stuff. It's 10:10. You guys have the rest of the day to work on your stuff. Okay, so have a good day, guys. Take care. Bye. Zane, try PDF, okay?
So, okay, hi. The problem is that it's not letting me submit anything. It just says that you already submitted once, you can't submit again. So that was my problem
You can't
at
submit
the
another
start.
file. You can't submit 2
Yeah,
files.
like I've tried. The thing is, it didn't let me submit all my files at once because it was like too powerful. So I
Okay,
decided to
so
like
okay, Howie, what's the file type? Is it a picture? Is it a
it's like a picture. It's like from
no?
my
That's the problem. There's a maximum size. Do
Mhm.
it as a PDF. And
Oh,
I
I could
realized
try.
I knew it was you because I'm thinking you're doing these big pictures. It doesn't take it. You need to have do the PDF.
Okay.
Just scan as a PDF. It should work. 'Cause you're
Okay.
the only one I'm having issues with. So I know it's your file type. That's why.
It is that, but also it's just not letting me submit another file, which even if it was PDF, it's just
Okay,
completely
try the
closed.
PDF so I can see. Just do it right now as a PDF because it's definitely
Wait,
is the
would I be allowed to like show you what I'm seeing? Because
no.
it just
What do you mean on your
says,
screen?
yeah, on my screen, all it says is you
Okay,
have already submitted to this folder and cannot submit again.
okay.
Yeah.
Okay, so what I'll do, let me just give me a second.
Yeah,
Stay
of
on the
course.
line.
Take your time.
Which one was it?
Um, so I just had to submit
Wh-
for one question for communication and thinking.
Is that was
Oh,
unit 3?
yeah.
Yeah, okay. So let me go and see. Mm. So communication and thinking, right?
Yeah.
and you already submitted, but it won't
Yeah,
allow
it
you to
was just one of the questions, you know?
um, okay, let me see here. What's going on?
Let me save it as a PDF, just so I can submit it right now.
So you need the 3 pictures? Can you just do
Yeah.
one PDF for all of them?
I'll do that. I can do that.
Okay, so let me. Uh, how do I do this here? Let me just say here. Give me a sec. That's weird. Okay, just hold on. Let me just check something. Hmm. Okay, try it now.
Okay, let me refresh. Yeah, no, it still says you have already submitted to this folder and cannot submit again.
That doesn't make any sense. You submitted two pictures already.
Yeah, I had one more question.
Yeah, I
to do.
know, but it's not. That's weird.
I know.
Mm,
Oh, it worked for communication. It's letting me submit
yeah,
something again.
because I just did. I did that one.
Okay,
I did that one.
thank you.
So yeah, so now it should work for the.
Thank
I
you.
didn't know. I didn't know which one you're checking. Yeah, yeah, it should work for it. Should work
Oh
for it
yeah,
now.
yeah, it's perfect now.
Yeah.
Thank
Okay.
you.
And yeah. Okay. So you're
I'll
good.
send it as a PDF this time.
Yeah. Yeah.
Okay,
Okay.
thank
Yeah.
you.
Bye.
Bye, have a great day.
Okay. You too. Eve. Eve, Sean, you there?